Good afternoon, everyone. We'll start the session within 5 minutes. So, వినిపిస్తుందా? Good afternoon, all. It's an immense pleasure to invite today's speaker, Dr. Ravishankar Paskuleti. So he did his PhD full-time from BIT AP University, Amravati, Andhra Pradesh, and he did his MBA from Acharya Nagarjuna University, Guntur, Andhra Pradesh. And currently, he is serving as associate professor in the Department of Applied Science and Humanities in Tirumala Engineering College, Andhra Pradesh. He has more than 15 years of teaching experience and served as HOD in Andhra Pradesh. He was published more than 17 research papers, out of which majority papers were published in Scopus and Web of Science, and the rest were published in UGC and ABDC. He served as a reviewer for two Scopus journals, and they are Journal of Computers in Education, which are Scopus and the Q1 and Web of Science, and Journal of Infrastructure and Policy and Development. These two journals are Scopus journals, and it is Q1 and Q2, and even Web of Science also. He was participated in more than 20 seminars, conferences, and workshops, and he was received Best Research Paper Award for his contribution on artificial intelligence, so in which he used the same model, that is structural equation modeling. And the paper entitled as Artificial Intelligence in the Pocket, Factors Influencing Generation Z's Intention to Use AI-Powered Mobile Banking Applications, in an international conference on the impact of AI-driven decision-making and agile management practices for sustainable development, held in Bangalore in the year 2024. So with this brief introduction, I'm handing over the session to Dr. Ravishankar. Sir.
Yes, sir. Thank you, sir. Thank you very much for your introduction, sir.
Okay, now you
Am I
can.
audible, sir?
Yes, sir, you are audible.
Yes, sir. So, good afternoon, participants. So, let me share my screen. I hope my screen is visible. Can anybody confirm? Can I continue?
Yes, sir, it's visible. You can continue.
Yes, good afternoon, participants. So, today our topic is structural equation modeling using SPSS and AMOS. SPSS stands for Statistical Package for Social Sciences, and AMOS stands for Analysis of Movement Structure. So first, let me briefly explain what is meant by SEM and what we need to do our analysis using structural equation modeling. So yesterday and today also, our organizers has shared the instructions to install SPSS software and AMOS software. So during our session, we have some hands-on also. So please follow step by steps. And I will give one template for all of you. You can prepare in Excel for analyzing your future data analysis. So let me start about SPSS. So structural equation modeling is a powerful multivariate statistical technique where we are going to use the complex relationship among observed and latent variables. So in many researches, we are going to propose various relationships, nothing but the hypothesis between the variables. We call it as variables or research constructs. So based on the nature of those variables, we may call those as observed variables, latent variables, dependent variables, independent variables, mediating variables, moderating variables, and so on. So this SEM combines the factor analysis and as well as path analysis to test the theoretical models and assess the direct and indirect effects and evaluates model fit of our proposed research model. And SPSS is often used for preliminary data analysis, such as descriptive statistics, which comprising of mean and mean, median, mode, standard deviation, variance, and so on. And also it tests the reliability of the data which we collected through our surveys. Reliability we will calculate using Cronbach alpha. And AMOS is an SPSS add-on. It specializes in structural equation modeling with a user-friendly graphical interface for drawing path diagrams and running CFA, confirmatory factor analysis, or full structural models. And the key features of structural equation modeling in MOS especially includes we can test the hypothesis, that is the causal relationships which we framed or which we proposed in our research, and we can handle the latent constructs with multiple indicators. Latent constructs means there are some of the variables which we can measure using 5 or 6 different questions. Suppose if you want to measure the marketing mix, so that is comprising with product, price, place, and promotion. If it is in case of services, people, process, and physical evidence. So here the marketing mix variable is called as the latent construct, and the multiple indicators are product, price, place, promotion, and so on. So this assess the model fit using the various indices. For example, I am given CFI, RMSE, and chi-square. CFI stands for that is comparative fit index. RMSE stands root mean square error of approximation. And there are some other model fit indices also, like GFI, goodness of fit, AGFI, adjusted goodness of fit, and so on. And this MOS also performs bootstrapping for non-normal data. And overall, together, SPSS and MOS provide a robust toolkit for researchers in social sciences, business, and health to validate and refine theoretical frameworks. Suppose if you want to test a model like this, so through our literature survey, literature review, we have proposed some relationship, nothing but the hypothesis. So the picture which you are seeing is one of the research model. Here we are not specifically define what are the variables. Here IV, it is an indication of independent variable, IV, independent variable. So left side you can see 3 independent variables, and in the middle that is mediator independent variable, and at the right we can see the dependent variable. If we see carefully in this research model, we have 6 variables, and the square box indicates that is an observed variable, right? So suppose if you want to test this research model, SPSS and MOS, that is the structural equation model, is the absolute perfect model to test this model. So all those right directed arrows which are drawn from IV to mediator, IV to mediators, and the mediators to dependent variables, all those are called as the hypothesis, or maybe the path relationships. Those are called as the path relationships. And if you see as a single entity, one IV to one mediator independent variable, that is called as one path. And that right directed arrow in that case is called as the regression weight. So, and also mediator independent variable to dependent variable, if you consider only those two constructs, only those two variables, even then also that is called as a path. That right directed arrow is called as a path. So here mediator impacting dependent variable. That means suppose if we draw 2 boxes, and if we draw a right directed arrow in between the 2 variables, then we called as that is the relationship between those 2 variables. That means that mediator independent variable impacting dependent variable. So depending upon, based on the literature survey, we are going to mention that that relationship is positive or negative. Means mediator independent variable is positively influencing dependent variable. That is the hypothesis we can frame. Or mediator independent variable is negatively influencing dependent variable. In this way, we can propose the hypothesis relationship. For example, we are interested in finding customers' mobile shopping intention through mobile shopping applications using the famous technology acceptance model. So this is the example I am going to take, and these are the variables I am going to construct. I am going to find out the intention, intention of the customers, whether they are going to use the mobile shopping applications for their online shopping. So this is the model which you are going to see. This is the famous technology acceptance model, TAM model, which is developed by Davis in the year 1989. So here the variables are perceived usefulness, perceived ease of use, attitude towards using that particular technology, and behavioral intention to use the technology. And that behavioral intention leads to actual system use. So this is the model developed by Davis. It is a very famous model. So based on this technology acceptance model, many studies have conducted many researches in the context of mobile shopping and e-commerce and mobile banking and smartphone adoption and even services relating to hospitality. Many hospital services, many studies have used this model. So I have taken this model as an example for our FDP topic. And coming to this model, so here, as earlier I mentioned, if we consider two variables, one independent variable and one dependent variable, so the relationship between those two is the hypothesis. So if you see how many paths we can get through this model. Suppose the model which we want to test has five hypotheses. So if you see the previous slide, so here we are ignoring two variables. One is external variables. I will explain about the external variables later. After completion of some analysis, I will introduce those. And actual system use, we are not considering that. So if you see, we are going to find out the intention, mobile shopping intention, that is the behavioral intention of the customers. And if you see the hypothesis, so if you, from this figure, you can draw the hypothesis. Suppose if you see perceived ease of use has a direct impact on perceived usefulness, that is one hypothesis. And perceived ease of use has an impact on attitude towards using. And then perceived usefulness has an impact on attitude towards using. And perceived usefulness has impact on behavioral intention, and attitude has an impact on behavioral intention. So these are all called as the hypothesis, the same hypothesis I mentioned here. So just just a minute. Lata raised a hand.
Lata madam, if you have any doubts, you can ask, ma'am. Hello. Hello, Lata ma'am, please respond.
Yes, madam. Lata ma'am, what is your doubt?
Hello. Lata ma'am, you continue, sir. You continue.
Okay, sir. So these are the hypotheses we are going to test. So the first, if you see the first hypothesis, perceived ease of use. So hereafter I am going to use PAU, that is the and perceived PAU has influence on PU, and PAU has an influence on attitude. So all these are the hypotheses which we have drawn from that technology acceptance model. Sir, again they raised the hand, sir. Have you unmuted, sir?
Yes, sir. Yes, sir. You can continue.
Okay, okay. Just wait, sir.
Yes, sir. What happened?
Nothing, sir. I am seeing a big window on my desktop, on my laptop. Once if they raise the hand, just I am trying to hide that thumbnail. Oh, okay, sir.
If there is a
Fine,
query, sir, you can check
fine,
in
fine.
chat box, sir.
Fine, sir. Done, done, done. Okay, so this is the model we are going to test, the same technology accepted model according to our literature review and according to our research objectives. So hypothesis wise, I have drawn this picture. Ease of use has influence on usefulness, and ease of use has influence on attitude, and usefulness has impact on attitude, and usefulness has impact on behavioral intention, and attitude has influence on behavioral intention. Then how we can test this relationships? So for testing this, first we need to go for we need to conduct a survey. Through the survey, we have to collect the data. So how we are going to collecting the data, and what we are going to ask the respondents. So first of all, we have to prepare a questionnaire for this. So that questionnaire has to comprise with some questions. We need to collect the responses from the customers, those who are using mobile shopping applications for their online shopping. So what are the questions we have to frame for this, and how we are going to frame that question? So let me open the questionnaires for this. So so this is the questionnaire we have to use to collect the data from the respondents. So if you see the first construct, that is the perceived ease of use, that is the latent variable which we are going to collect the data using four questions. So if you see here, perceived ease of use, that is going to measuring with four items: PAU1, PAU2, PAU3, and PAU4. So these are the questions we are going to ask to the customers. So what they are going to respond? So I find mobile shopping apps easy to use. So this is one of the question. And the second is, it is easy for me to learn how to use mobile shopping apps. And third is, interacting with mobile shopping apps does not require a lot of mental effort. And fourth is, I can use mobile shopping apps without much technical support. So these are the four questions we are going to ask for this particular research construct, that is perceived ease of use. So based on the responses from these four questions, we are going to measure the construct perceived ease of use. So here in the right side, they are going to select. Suppose if they feel that that is good, they may opt for 4. So here we are going to use a 5 points Likert scale, a 5 points Likert scale, and which is ranging from 1 to 5, strongly disagree to strongly agree. Suppose if they have choose the response of 3, that is the neutral, neither agree nor disagree. So like this, we are going to collect the data for all research constructs. So all these are called as the research items. So these are the items, means suppose if you take perceived usefulness, so that perceived usefulness is measured with four items: PU1, PU2, PU3, and PU4. So like that, how many number of research constructs in our research model, we have to prepare these questions. Then where to get these questions and how we have to modify. So these are the questions developed by Davis. This is from the technology acceptance model. So here we have to give the reference also when we are reporting the same in our research paper. So all these items were adapted from Davis 1989 from the technology acceptance model. Suppose if you are using this construct from one reference, and this construct from another reference, and this construct from another reference, in the report you have to prepare this attitude towards mobile shopping was adapted from some XYZ et al 2024, like that you have to report. So this is the questionnaire we need to develop when we are collecting the data from the respondents. Then how we are going to use this data for our analysis. So from here, we are going to use the tools SPSS and MOS. So how we are going to use? First, Right. Sir, just a minute, sir. I hope my screen is visible. Right. So from the data which we collected through the survey from the respondents, we are going to test all these. So as a part of structural equation modeling, we are going to do all these analysis. So we are going to start from normality test, and then a reliability analysis, and then convergent validity, and then discriminant validity, and then structural model evaluation. So these are the 5 steps which we are going to follow for running our structural model. So first, what is normality test and what is reliability analysis? So step by step, let me explain. So first we have to prepare SPSS data set for doing all these analysis. So I shared the SPSS file, and the organizers has shared that SPSS file with the participants. So those who have downloaded the SPSS and installed, so please open that SPSS file, and I will explain how we are going to prepare that SPSS file and how to open that, how to save that step by step. So so the point which we need to remember here is, so we have collected the data, and we have we are going to analyze the data, that is the survey data. So what are the steps? So if you see the data, first we are going to load into the SPSS. So please open, participants, please open the SPSS file which we shared with you. And if anybody has any doubts, please please ask me now. Organizers, if anybody has any doubts, please unmute their mics. Is it open? So first, normality test. So let me explain one more point here. Then how I have created this data file. So maybe you have doubt. Then how we are going to create this data file? So first, open the SPSS file. So suppose so if you open the SPSS software, it will displays like this. So it has two windows. One is data view. In the bottom, you can see here, one is data view and second is the variable view. So what is data view and what is variable view? So suppose in the data view here, we are going to enter the variables. So whatever the variables we have collected, whatever the variables we have used in our research, so we are going to enter the variable name. Suppose here in the name, it is first we have used perceived usefulness. So here we can type PU. And then PU has four research items. That is, one is PU1, and then PU2, and then PU3. Like that, we have to enter PU1, PU2. And whether it is a numeric variable or string variable. Suppose if it is the name or if it is the gender, like gender, male, female, like that. So those are considered as the string variables. If it is any number, then it is the numeric variable. Like that, we are going to enter one by one. And here the width is nothing but the space we are using for that, and how many decimals we can use, and what we are going to label. Suppose it is the label is PU for this. And the values which are ranging from 1 to 5. Here we are going to enter value 1 to 5. One here it is one as strongly disagree. Simply clicking add, and then 2. it is disagree, and then 3 neutral. Like that we are going to enter like that we are going to enter, right? And finally measure whether it is a normal scale. This is the scale variable. So like that we are going to enter manually. Without entering manually also, we can directly load the data. So for that, what we are going to do is, let me share another screen. I'm stopping this SPSS. Sir, Lata has raised her hand. Could you please ask what is their doubt? Lata madam, do you have any doubt?
Yes, Lata madam, you can ask the question. JSP ma'am also raised the hand.
Those who are who raised their hands, please ask your doubts.
Sir, am I audible, sir?
Yes, yes, madam. Yes, madam.
Sir, is it mandatory to use the mediator variables in the CM
It is
model?
not mandatory, ma'am.
Not
It is
mandatory.
not mandatory. Suppose we want to directly measure the behavioral intention. So we can use the two hypotheses. Perceived ease of use has impact on behavioral intention, and perceived usefulness has impact on behavioral intention. That's it. There we are using two variables. It is not necessary or not mandatory to use mediating variables and other variables, moderating variables also.
Okay, sir. Suppose if you use, yes, sir.
Yes, ma'am. We have to, basically we will use two variables. One is dependent variable and independent variable.
Yes, sir. So suppose if we use moderating variables,
Yes,
is it
ma'am.
mandatory to have some questions or items for that moderating variables?
Absolutely, ma'am. Absolutely. Suppose, let me show our same model. Let me share the screen again. So if you see our research model, ma'am. So here attitude, if you see the attitude, that is the mediator variable.
Yes, sir.
Because if you see the relationship between perceived ease of use to behavioral intention, there is no direct relationship between perceived ease of use to behavioral intention. But attitude is in between the perceived ease of use to behavioral intention. That means perceived ease of use impacting attitude, and attitude is impacting behavioral intention. That means attitude mediating the relationship between perceived ease of use to behavioral intention. Also, if you see perceived usefulness to behavioral intention, we have direct relationship H4. And if you see H3 and H6, that means perceived usefulness has impact on attitude and attitude has impact on behavioral intention. So here attitude is acting as a mediator between perceived usefulness and behavioral intention. In our research model also have the mediating variable. Suppose in our model, if you remove H4 and H5, what left? That is perceived ease of use, perceived usefulness, and attitude. Is it clear, ma'am?
Yes, sir.
Even in this case also, we have H1, H2, and H3. If you ignore H4 and H5. So if you see H1, what is H1? Ease of use has impact on usefulness. And ease of use has impact on attitude. And usefulness has impact on attitude. Here also, usefulness is mediating the relationship between ease of use to attitude, because H1 and H3, these two directly indicating the attitude. So here also you can ignore H1. If you ignore H1 and H4 and H5, we have two hypotheses left, H2 and H3. Okay, ma'am. Then there is no mediating variables in our research model.
Okay, sir. So one more thing, do we need to have questions or items for the dependent variable in the questionnaire, sir?
Absolutely, ma'am. We have to collect the data for the dependent variable and independent variable.
Okay, sir. Thank you, sir. Thank you so much, sir.
Yes, thank you. Any more doubts? Okay.
Yes, Lata madam, you can ask. I think she raised the hand. Lata ma'am, if you have any doubts, you can ask. Okay, sir, you can continue.
Okay. So let me share the data file again. For screen sharing, I'm sharing the screen. It is showing your screen sharing is passed. So let me share my entire screen then.
Hello,
Yes.
sir, am I audible?
Yes, madam.
Sir, like in the beginning, you were just explaining about the TAM model, no?
Yes, madam.
So, do we have any advanced version of that model, sir? Like, can we use in case?
Any model we can use, ma'am. Just it is an example I have taken. You can also take UTAUT model. That is UTAUT.
model.
Yes, ma'am. UTAUT, UTAUT2, or SDT, self-determination theory,
No,
or
which
ECM,
advanced version
expectation
would be
control.
helpful, sir?
Just it is for an example I have taken this model, ma'am. Just this is an example. So how we are going to use the structural model for explaining that only I am taken. We can take n number of variables, ma'am, n number of theories for conducting structural equation model.
Okay, sir.
Actually, I have collected the data regarding that model, and I am explaining all those. That's why I have shown that structural equation model. You can take UTAUT model, Unified Theory of Acceptance and Use of Technology model for your research. The procedure is common for all models, ma'am.
Okay,
You can
sir.
take any model, ma'am. That is not at all a problem.
Okay, sir.
Just our session is regarding what is structural equation modeling and what are the steps in structural equation model and how we will do the structural equation model and how to report the results of structural equation modeling. Okay, ma'am.
Okay, sir. Thank you.
Okay. Okay, ma'am. So this is the research data. Okay, so I think my screen is visible. Suppose if you see the data which we collected. So in early stages, I have shown what is the questionnaire and how we are going to collect the data. So here, if you see the first question, so here you can see, I find mobile shopping apps easy to use. So these are all the responses we have received: neutral, agree, strongly agree, disagree, strongly disagree, and so on. So I have shared SPSS data file with you. So all those are already loaded, and overall 307 responses I have collected in one of my research. So this is one of my research data. So now we are going to use this data for our data analysis. How we are going to use this data? First, we can directly load this data to SPSS, and another way is we can code this data in Excel, and directly we can upload this data to the SPSS. How we can code this data? So we are going to code this data. So suppose if you see the first one, A1 cell, This is I find mobile shopping apps is easy to use. So this is item 1 of perceived usefulness. So here we can code that is PU1. And the second one, it is easy for me to learn how to use mobile shopping apps. This is the second question. So here we can type PU2. Like that, we are going to code all those. This is PU3, and this is PU4, and this is PU1, and so on. Like that, we can code. So if you see, I'm already coded all this data. So it is PU1, PU2, PU3, and so on. So these are the research items we have used for our research. Maybe you have doubt. Then how all these neutral, agree, strongly agree, we have to code. So here we have to code that strongly disagree as number 1, disagree as number 2, and neutral as 3, and agree as 4, strongly agree as 5. How we have to code this? So you have to select all this. This is the very shortcut. So we have to select all the responses for coding these responses. So from first response to last response. So we are going to select all these. I am selected all these. I hope it is visible in the screen. And then we have to replace the strongly disagree with number 1. So simply click Control F. So one window will appear. So here we have to select replace. So what you have to find and what you have to replace with. So type strongly disagree. So this is what we want to replace. We want to replace with number 1. So after entering these two, simply click replace all. If you click replace all strongly disagrees will convert into 1. I think you are able to see in the screen. So all ones, those are strongly disagrees. And then convert strongly agree. Strongly agree. So strongly agree we have to replace with 5. The point which we need to remember here is, suppose if we change disagree immediately after strongly disagree. After 1, actually our serial number is number 2. We have to convert disagree into number 2. But in some cases, we may use 7-point Likert scale and a 9-point Likert scale. At that time, what will happen is strongly disagree, that disagree will replace it with number 2. So that's why what we are going to replace immediately after strongly disagree is strongly agree. So if you simply click replace all those strongly agrees will converts into number 5. And then you can change disagree. Why I am changing disagree is because we change disagree. If we change agree into 4 here, disagree will convert into DIS4. That's why first we need to code disagree as 2. If you click replace, all those disagrees will convert into number 2. And then you can select agree into agree as 4. Click on replace all. And then neutral as 3. Replace all. You can simply close. So this is how we are going to code all our research items into the numbers. Anybody has any queries? Please ask me. So from here we are going to load this data into SPSS. So this is how we are coding the survey data into our codes. Then how we are going to create this SPSS file? So I'm already shared this data with you. Those who have who are installed that SPSS software, please open directly. Please open directly. So now what I am going to do is I am opening SPSS. So I am sharing my entire screen so that you can follow what exactly I am doing here. So I am opening SPSS. It may take a few seconds to open. Please open SPSS in your systems. Yes, it is open. So from here directly we can open. So all these are the early works. So here a separate icon, open another file. So simply click on open another file. So please select the location. I have shared in desktop folder Acharya, and here see file type. Here we have Excel file. So we need to select this Excel file here. Before selecting the file, we have to select Excel. So if we select Excel, so whatever the Excel forms, all those opens here, the survey data. So please select that survey data and open. So it will ask, suppose in our Excel sheet has 4 or 5 sheets. So here we have the data that is coded. This is the output file and this is the SPSS file. So this is the data file I have shared with you. So this is how we are going to create the SPSS file. So simply let me have a quick review about creation of SPSS file. So first we have created, first we have opened the SPSS and we have selected here. From here also we can click import data from Excel. So if you click this Excel, that will ask the data file. We have to select the location, and if you open and click OK, then our data will opens automatically. So this is how we are going to create an SPSS file. So now this data is ready for our analysis. So this is the basic work we have to do for collection of the survey data and for the preparation of our SPSS file. So let me move to our slide. So this is our research model, and now these are the analysis we have to do. So I think so this is the questionnaire, and these are the procedures for creation of the SPSS. So how we are prepared our SPSS, how we have prepared our SPSS data. So our data is properly organized and include variable names in the first row, and remove any merged cells or specific formatting, and save your file, Excel file, preferably XLSS. And we have opened the SPSS, and we have imported from go to file, open data, and change the file type to Excel, and locate and select the Excel file and click open, and configure the import settings. So here we already selected all these by default, all these, and finally we have to save that data in the form of .sav. So this is the procedure for creating SPSS file, and this is another method, simply copy pasting. So once if we open our SPSS file, we can copy paste the data directly from Excel to SPSS. Let me show how that is also. So this is our first variable, that is PU1, Suppose I have deleted this PU1, right? So if you open the Excel file, so if you open that Excel file, so this is the Excel file and this is what we coded, right? So PU1. So from here, PU1, select that PU1 file and copy this and open the SPSS file. And from PU1, from first cell, it is PU1. You simply, if you click Control V, that will paste automatically. So this is the data. Like that, we can simply select all and simply we can copy paste. Suppose I want to select all. I have deleted all cases removed. So here, if you open the survey data, this is the Excel file. So from Excel file, this is the first item to the last item. So we have selected all these data and we have opened SPSS file, and in SPSS, the first cell, select the first cell and simply click Control V. So the data is pasted. So this is how we can create the SPSS file. And later you can save this data by simply clicking this save icon. That is, I think you are able to see the save. If we click save, that will ask the path where to save. So you can select any location where you want to work, and you can type that is FDP file underscore, it is the tab mode. Like that, you can save this file. So now the data is saved and this is the output window. So this is how you are going to save an SPSS file. Any doubts till now? Please, anybody, participants? Right. Next, step 2. So after creation of the SPSS file, first what we need to do in structural equation model. So first we have to test whether the data is normally distributed or not. So here one of the method for the normal distribution is the skewness and kurtosis, right? So first we have to test whether the data is normally distributed or not. So how we are going to calculate, or how we are going to see the skewness and kurtosis values of our survey data. So to calculate this, we need to follow the syntax. So in SPSS file, we have to click Analyze and then Descriptive Statistics and Frequencies. So what is this? So this is how we can calculate, analyze, descriptive statistics and frequencies. So if you click on frequencies, this file will open. So let me share you directly from the SPSS file. Let me open the SPSS file again. So meanwhile, let me explain. So here, right. So our data set is open. So please please click on Analyze. So after clicking Analyze, you will see the list, and from that list, from the second, top to second, descriptive statistics, click on frequencies. So if you click on frequencies, a separate window will open, right? So it is already selected. So here we can select. If you click on that item, that will select, that will highlight with yellow. So please select PU1 and click this right directed arrow, then that will move to that variable box. So next PU2 to right. So similarly, you can select all. Simply from the first item to last item, click on Shift and select and click the right arrow. So then all items will move, right? So after sending all these left side items into right side variable box, and you can simply click on statistics. So here we have statistics. So from the statistics, check here skewness and kurtosis. You can deselect all. By default, all those others are deselected. Simply you can click on skewness and kurtosis. So click on continue. Then it will runs the analysis, and you have to click the OK. Right, so this is the SPSS output. So from the first table, it is the statistics. So from the first table, you can see what is the skewness and what is the kurtosis. So copy or click on click right mouse click and select copy and open an Excel file, any Excel file. So I am taking this file, our data file, and simply I am pasting here. Right, so skewness, standard error of kurtosis, this is not required, delete this cell, and standard error of kurtosis, delete this cell also. These are not required, and missing and valid, these two are also not required, delete these two. So now we have our data. So here skewness and kurtosis. So these are the normal distribution, and these are all the values. And if you want to see, simply you can copy and you can paste a special transpose. If you click, now we can report these values in our data, in our report. So please check the skewness and kurtosis values. Based on the threshold values, we can say the data is normally distributed. If the data is normally distributed, we can proceed for further analysis. So let me move to the slide. So like this, we are
the query in chat. How to import data to SPSS from MS4. That is one of the query from participants.
Sir?
The chat box, you can find one query. How
Yes.
to import data to SPSS from
SPSS output, sir? Are you talking about SPSS output? Yes.
check
So
the
this is
chat
output.
box, sir.
Yes, sir. Chat. Okay. My voice is not open. How to import data to SPSS from MS Word? Okay. Sir, SPSS data means you are asking about output data. So simply if you move your cursor point, so this is the output table statistics. You can select this table. First click and right click. If you click if you give right click, that will open. So you can simply copy, right? And you can open any Word file. You can create a new Word file, and so let me minimize and open one Word file for you, sir. So I'm creating one Word file, MS Word. We have already copied the file, and you can simply paste Control V. From here, we can remove what is unnecessary and what is necessary, and we can prepare our place. Whether it is MS Word or MS Excel or even any other document, simply selecting that table which we want to paste and copying and pasting in Word or Excel, anything. Is it okay, sir? Right. So this is the skewness, and these are the kurtosis values. So now, how we can say our data is normally distributed? So this is the procedure we followed, selected skewness and kurtosis, and these are the outputs we got. And from here, we can say what is the acceptable range of skewness and kurtosis. That is, the skewness value should be less than modulus 2. Whether it is minus or plus, it is not at all a matter. That should be less than 2. So if you see the all skewness values, the maximum value is 1.106. Right? And if you see the kurtosis values, we can consider the kurtosis values less than modulus 7. So all these skewness and kurtosis values are under the recommended levels. So we can conclude that our data is normally distributed, and we can proceed for the further analysis. And next one, we have to calculate the normal distribution, that is the reliability statistics. So normal distribution is completed. through the skewness and kurtosis, and now we have to calculate the Cronbach alpha value. So actually we have to use this formula for calculating Cronbach alpha, but in SPSS it is not necessary to use this formula. Directly we can calculate the Cronbach alpha value. So how we are going to calculate the Cronbach alpha in our SPSS file? So simply we have to go to analyze, and we have to select the scale, and we have to select the reliability analysis. So let me open the SPSS file again. So this is the file. Now we are calculating the reliability. Normal distribution is completed, and now we are calculating the reliability analysis. So we have to click analyze. Those who have the SPSS software, you can please open the same data file, and we can follow accordingly. We have to click analyze, and we have to click scale, and we have to click reliability analysis. If you click the reliability analysis, so the window, one separate window will display. So here we have to calculate the reliability of each construct. The construct is first is perceived usefulness. It has 4 items. So select PU1 and press shift and select PU4. Then 4 items will select, and click on right directed arrow. Right. So we have selected perceived usefulness constructs, perceived usefulness items. So now what we have to do? So here if you see the bottom to that, by default it has selected alpha. So we have to select alpha, and we can click OK. So if you click that output file, it will display what is the Cronbach alpha. So you can see the output, the Cronbach alpha value is 0.858. Right. So this is the Cronbach alpha value for perceived usefulness. And similarly, we can go to analyze, scale, and reliability. And now we have to select these perceived useful items, and we have to send this to the left side box. So click left arrow, and next select next 4 items, and send them to the right side. Now these are the items for perceived ease of use, and click OK. Now 0.857, this is the Cronbach alpha value for perceived ease of use. And similarly, you can select the next items. I have sent PUU to the left side, and attitude 4 items I have selected and sent to the right side, and click OK. So the Cronbach alpha value for this item attitude is 0.847. Right. And the last variable we have to calculate, that is the behavioral intention. Go to analyze, scale, reliability analysis, and select these 4 items and send them to the left side, and select the behavioral intention items and send them to the right side, and click OK. So 0.847. So all these are the reliability values. How we are going to report these? So reliability analysis we have calculated, and so this is the procedure we have to follow: analyze, scale, reliability analysis, and selecting those 4 items and sending to the right side and clicking on OK. So after doing this, we got these values. For perceived usefulness, it is 0.858, perceived ease of use 0.857, attitude 0.847, and behavioral intention 0.847. So what is the acceptable value for Cronbach alpha? So Cronbach alpha value should be always greater than 0.7. If it is greater than 0.9, that is the external internal consistency our data has. If it is in between 0.8 to 0.9, that is a good internal consistency. If it is in between 0.7 to 0.8, that is the acceptable internal consistency. If it is less than 0.7 to 0.6, that is a questionable internal consistency. And if it is less than 0.5 to 0.6, that is very poor internal consistency. And less than 0.5 is an unacceptable internal consistency. Right? So this is the reliability analysis report. And then we have to go for MOS. So using SPSS data file, we can do only the descriptive statistics and as well as the normal, that is the reliability analysis. So from here, if you want to test the hypothesis, if you want to test the relationship between 3 or more number of variables, it is better to go for MOS. But actually, we can also use the regression or ANOVA to test the relationship between the construct. But where we have to do some bundle of analysis, but MOS will reduces all those effort, and we can use MOS from here for further analysis. So MOS is bundled with SPSS, and it is suitable for structural equation model. Then how to open MOS? So these are the steps we are going to follow in MOS file. So first we are going to open the MOS file, and we are giving the SPSS data set to MOS, and we are drawing the variables what we are going to test, and we are selecting the estimation in the outputs, and we are drawing our full model, and we are running the model. These are the steps we need to follow in MOS. So MOS. So let me open the MOS file. So this is the MOS file. So let me start. So how I have drawn this confirmatory factor analysis figure. So I will explain step by step. So let me open a new file so that you can understand how I have drawn this. So those who are installed MOS, please open your MOS software. So if you open MOS, it will display like this. All these left side, these are all the toolbox, right? And these are the indicators under which path we are working and all those. So this is the space. So here we can draw our model. So please see what is your research model. So accordingly, you can draw your research model. So if you see, this is our research model, right? So technology acceptance model, perceived usefulness, ease of use, attitude, and behavioral intention. So please open that. So here, please see the toolbar. So first one, it is, I think it is very user-friendly software which automatically suggests the users what that is. So it is an observed variable. For observed variables, we have to draw that, and the circle, that this square is for observed variables and this circle is for unobserved variables. First, we are going to draw this. And if you see, draw a latent variable or add on indicator to a latent variable. So we have collected the data for the latent variable. So we have to select this draw a latent variable icon. So simply select that draw, that will highlight. So simply click on this space, right? So we have to adjust the size, otherwise the space will run. Okay, so if we click first, one circle will displace, and in the same space we can click 4 times, because perceived usefulness has 4 items. So this is the latent variable for perceived usefulness, right? So if you see the icons in the toolbar, let me explain one by one. So the left directed arrow, that is drawing path relationship, and this is the 2 directed arrow is for covariance, and this symbol is for adding an error term, which is an add-on, and this is for figuring the title, and all these are the list of variables in our model, and these are the data. So one by one we can see, right? So if you see this one, rotating the indicators of a latent variable. So if you select this, rotate the indicators and move to that our variable, and if you click, the variable will rotates. So for drawing the confirmatory factor analysis, we are going to position this item like this. And if you see a symbol, that is lorry, that is a moving object, please click that object and you can move to the top, right? So we placed that in the top of the surface. And if you see the left to that lorry symbol, duplicate objects. So simply click that and come to the latent variable, and simply you can click and drag. What you have to do is you have to click and drag. So if you click and drag, the same variable will copies. So how many variables we have? We have 4 variables. 3 variables will comprising of 4 research items, and 1 variable has 3 research items. So I have copied 4, right? So here if you see left side, that is one arrays object. I am deleting the 4th item of the last object, because that behavioral intention variable has only 3 constructs. So now here if you see the one finger object, that is selecting. So please come to the variable and double click on it. If you double click, one window will open. So here we can name our variable. So variable name, so here I am drawing, that is PU, perceived usefulness. Simply you can type the perceived usefulness. And second is simply you can click on that variable, that is perceived ease of use. And third, that is attitude. And fourth, that is behavioral intention. Simply selecting and typing, right? So this is how we are going to naming the variable. Next, what to do? So here these are the unobserved variables, actually perceived usefulness. We have not measured in our research questions directly. We have used some questions to measure these items. Then how we are going to add those variables in our model? So if you see the left side, one Excel file type icon, that is selected data files. Left side, I think you are able to see here, left side where my cursor point is showing. If you click on that selected data files, that will ask from where we need to upload the data. So we have created one SPSS file. We have to select the location of that SPSS file. If you click on that icon, this window will appears, and select file name here, right? So, and that will ask from where. So I have saved my desktop Acharya folder, and this is the XPSS file, FDP file 10. So this is the data I have saved, right? So whatever the data you want to open, you can select and you can open that, right? So now the data is loaded. So from here, what we have to do is we have to load the items, right? PU is measured with PU1, PU2, PU3, PU4, and PUU is measured with PUU1, PUU2, like that. So there are 2 ways for adding those items into our research model. First is simply double clicking on the box and selecting PU1, and double clicking and selecting the next one, that is PU2, and simply selecting PU3 and select PU4. So this is how we can enter our data. Or else there is another method for adding our research items into the model is, so if you see the left side icon box, so here it is an icon list variables in data set. I think that is highlighted. So if you click on list variables in data set, one separate window will appears in our working file, in our working space. So here we can see what are the items in our uploaded data set. So from here, so we have typed PU1, PU2, PU4, and so on. So next we have to add the PUU1. So for PUU1, so simply go to the PUU1 and select, click and drag and open in this box, PUU1. And next PUU2. Simply select, click and drag and release in the respective box, and PUU4. And next attitude, attitude 1, attitude 2, attitude 3, attitude 4. Next behavioral intention, BI1, BI2, and BI3. So this is how we are going to add our research items into the model, right? So after that, what we have to do? So here all those left side error terms we need to fill with error terms E1, E2, E3, E4. How we are going to write that? So here also we have a procedure. Simply going to that circle and double click on the circle. We can enter the variable error term as E1 and E2 and E3 and E4. And like that, here also there is another shortcut for adding all those error terms. Here, if you see the pop-up menu, there is a icon called plugins. So if you click on plugins, that will shows seven. That will show seven indicators. So if you see the third one from bottom, name unobserved variables. If you click that name unobserved variables, by default it will fill, right? So these all these are the items we have loaded in our model, and now we are ready for the running analysis. So what we are going to do in the confirmatory factor analysis is we have to draw the covariance between all the research variables, right? So if you see the two directed arrow, so simply select all those. So from PU to from one variable to other variable, we have to draw the covariances between all the research variables. And instead of doing this, we can do one more thing. That is, what we can do is simply we have to select all the research items. So if you see the thumb, select PU, PAU, attitude and BI. So if you select, that will highlights in blue color by default. And again, simply go to plugins and draw covariances. If you click on the draw covariances, it will automatically draw the covariances between all the research constructs, right? Suppose if it is in zigzag order, we can modify with this magical tool that is touch up variable. If you see the left side icons, we can see the touch up. So simply select that icon and click on that variable PU. So by default, it will automatically readjust, right? So now these are selected, all these are in blue color. So if you see the left side icons, go to the deselect all objectives, right? You click deselect all objectives, then those will appear normal. So this is how we are going to draw a confirmatory model, right? Now we are going to run this analysis. Then how to run this analysis, right? So if you see the left side icon, so analysis properties. So let me move to the model so that I can explain step by step. So this is what we did. We have opened the MOS and we have loaded the file, and all these are various drawing toolbars, and this is the observed variable, and this is the naming an objective, and from here onwards we are going to run the analysis, right? So how to run the analysis, right? So this is the model we have drawn, right? So first we have to give what are the analysis we need to the model. So please select the analysis properties from the left side icons, analysis properties. If you click that left side properties, analysis properties, one separate window will appear. By default, you may see the maximum likelihood model. Please select the maximum likelihood model. If we found any other option is highlighted, and don't move any other things, and go to output, right? Ignore all others, go to output. So here select minimization history and standardize the estimates and modification indices. Sometimes we can select this direct indirect effects to calculate the mediating and moderating effects and all those, and squared multiple correlation, we can select all those, but the basic things are minimization history, standardized estimates and modification indices. After selecting those, you can close this window, right? So if we close that window, now we are ready for our analysis, right? So now we have to calculate our model. So for calculating, we can go to analyze and calculate estimates. So this is one way of calculating our analysis. And other way is that is the direct analysis. So here is an icon that is calculate estimates. So you have to click calculate estimates. So if you click, so right side we can see the process. So now the analysis is completed. So how do we know the analysis is completed? So if you see here are two icons. So these two icons indicates our model, whether the analysis is completed or not. So here one right upper arrow red mark, if it is highlighted, that analysis is completed. If you click on that red icon, the values will automatically appears in our research model. So by default, the model will shows the unstandardized estimates. We can see in the left side, we have to click on standardized estimates for all our analysis. So if you click on standardized estimates, now this is the confirmatory factor model we can report. Now we can copy this picture and we can report in our paper, right? So for copying this, if you see the left side, here is an icon, copy the path diagram to the clipboard. So if you click this copy to path diagram, and you can select any document where you want to paste, simply click Control V. If you click on Control V, that will appear in our Word document, right? And we can adjust this picture, we can crop or we can resize using the Word, right? Word features, right? Or else if you want to reduce the size, you can hold and drag, right? So this is how you can copy paste the path diagram. I am repeating again. So go to the path model and you have to select the copy the path diagram. That is the icon you can see in the toolbox, right? Copy the path diagram to clipboard. Click on that and you can open any document where you want to paste, and you can paste anywhere you want. Control V, right? So if you paste, that will automatically appear. So now what we have so far done, so we run the analysis. Now we have to calculate the composite reliability and average variance extracted to confirm whether our data is fit for proceeding for the structural model, right? So we run the analysis and how to see the factor loading value. So if you see the path diagram, so there are some values. Suppose if it is PU1, that is 0.82, PU2 0.67, and so on. So where do we get all these values? So here in the left side there is an icon view text. If you click view text, one output window will appear, right? So this is our model estimates. Our model chi-square is 156.085 and the degrees of freedom is 84. So if you see, there is a list in the output file, right? So in the output file, note for the model, this is the note for model, and next is that is estimates. Click on estimates. So this is the output what we need exactly, right? So these are the loading values of our research model. These are all the item loading, right? So now we have to do some analysis by using this standardized regression weight. So now we have to copy this table from this analysis MOS output to some Excel file, right? So for this, first what you have to do is click at this area, and if you click that box will highlight with a dotted line, dotted square, and click right click, give right click, and copy this table, right? And open an Excel file, and you can paste this Excel file, right? Simply copy and pasting in the Excel file, right? I am repeating, whatever the output we got, click the table which we want, that is the standardized regression weight, right? Give right click and select copy and open Excel file and paste. Simply pasting. That's it. Right? So after this, what we have to do? So now we have to calculate. Let me go to the, right? So we run this analysis. We did all this and almost practice. What we have to do, right? So first we analyze the measurement model. The measurement model, first we have drawn the model and calculated the factor loading. And based on the factor loading, we have to calculate the average variance expected and the composite reliability. So what is average variance expected? Average variance expected is the average value of the item reliability. What is item reliability? Item reliability is the square value of the factor loading. What are the values we got just now? So if we square these values and take the average of these square values, that is called as average variance expected, right? And then we have to calculate the composite reliability. So I'm requesting the participants, please open an Excel file and please paste the output of the MOs in the Excel file. Suppose if you are not downloaded the SPSS file and if you are watching through the phone or through your laptop or desktop, if you have laptop and desktop, please open an Excel file. Now I will give some steps to calculate the composite reliability and average variance expected. You can use this as a template for your future researches, right? So you can create an Excel file and you can save that file. And in future, whatever the factor loadings you got in your researches, simply copy paste those factor loadings in the table. By default, automatically you will get the composite reliability value and average variance expected value if you create the Excel file now, right? Right. So for calculating the composite reliability, this is the formula we are going to use. That is the sum of standardized loading square to sum of standardized loading square plus measurement error, sum of measurement error. So how we are going to calculate all these? So let me open the Excel file. Right. So these are the values we got. PU1, this is the estimate. These are the estimates, right? So see the left side box. So these are the values. Now we have to calculate, what we have to calculate is the first one is the average variance expected. So how we are going to calculate the average variance expected? So here I have calculated the average variance expected. So these are the factor loadings. These are the factor loadings we got, right? So from here, create a table. First, create a table that comprising of all these, right? From MOS output, we get this table. Now, create a column. So I am showing you directly. So we have copy pasted, right? This is the table we got. And now what we have to calculate from here is all these we have to calculate. So prepare this template. First, item reliability, right? So item reliability is nothing but the square value of the estimate. The estimate means this is the loading value we got from this MOS. These are the estimates. We also called it as the factor loading, right? So open this Excel and we have pasted all these loading values and item reliability. First, we are calculating the item reliability to calculate the average variance expected. So item reliability is the square value of the estimate. So here apply a formula that is equal to estimate value E5 into again same value E5 into E5. Click enter. I am repeating. Item reliability, first we have to calculate we have to calculate the item reliability by squaring the estimate value, right? Formula is simply that is the multiplication of the same cell equal to estimate value, that is the E5 cell into E5. Click enter. If you enter, the item reliability value will automatically appear. We have to calculate for all. So in Excel, the benefit we have is simply selecting that cell, click and drag. If you leave, that will automatically calculate the item reliability, right? And next we have to calculate the measurement error. So the measurement error, how we are going to calculate is the measurement error is equal to 1 minus the item reliability, right? So I am repeating again, measurement error is the value that is subtracting the item reliability value from 1. 1 equal to 1 minus item reliability value, right? So that is the formula, and simply click and drag. If you click and drag, all the delta values, measurement error values will come into our Excel. Now we have to calculate the average variance extracted. So as earlier said, average variance extracted value is nothing but the average of the item reliability. So the first one, if you see the first construct perceived usefulness, that is PU1, PU2, PU3, PU4, and we have to calculate the average, right? So that is the formula is equal to AVERAG, average these 4 items, that is the item reliability values. So please check the formula for that. If you click enter, that will automatically calculate the average variance extracted. Next for PUU, same, equal to average. What are the item reliability values for PUU? These are 4. PUU1 to PUU4. Close the bracket and enter. And similarly for attitude, equal to average. What are the item reliability values of attitude 4? And click on enter. And similarly for BI, equal to average, bracket open, BI item reliability value. So these are the average variance extracted values for our research constructs. So what is the acceptable level of average variance extracted is that should be above greater than 0.5. So if you see our research constructs all have greater than 0.5 AVE value. So our research model has good AVE value. So we can proceed for the further analysis, right? And next step, what we have to calculate is construct reliability. Let me show you the formula for construct reliability. So the construct reliability formula is this: standardized loading, the square value of standardized loading divided by the square value of standardized loading plus sum of measurement error. So now we are going to apply the same formula in Excel. How? So go to the Excel file. So just give me a minute, sir. Sorry for the interruption, sir. So now we are. Am I audible? Yes. Now we are going to calculate the composite reliability. So this is the formula for composite reliability. So we are going to calculate. So here we are going to calculate the sum of factor loadings, because we have to calculate the square of factor loading values. So here we are going to use one formula that is equal to sum of factor loading values. So what are the factor loading values? Those are the estimates, right? So similarly, equal to sum of factor loading values for perceived ease of use, and equal to sum of attitude factor loading values, and next equal to sum of behavioral intention loading value. Click on enter. So if you see, if you use this formula, you get the sum of factor loading values. So what is the formula? Standardized loading values. This is the sum of standardized loading values we have calculated, right? And next, what is in the denominator? Sigma measurement error. So now we have to calculate the sum of measurement values, sum of measurement error. So these are the measurement error values. Now we are calculating the sum of this, equal to sum of these measurement error. Enter. Next, sum of delta values for perceived ease of use. Those are the delta values for perceived ease of use. 1, 2, 3. Next, equal to sum of attitude measurement delta values of attitude. Enter. Next, for behavioral intention, equal to sum of measurement error values of behavioral intention. So we have calculated the sum of the standardized loading values and sum of measurement error values. Now for composite reliability, what is the formula? The formula which we have shown is sum of standardized loading whole square by sum of standardized loading whole square plus measurement error, sum of measurement error. So see how we are going to calculate. Equal to, within bracket, sum of factor loading, this value, into the sum of factor loading, that is the square value we have calculated, divided by, again, sum of factor loading into sum of factor loading, next, plus measurement error, plus sum of measurement error. So this is what we are going to calculate now, right? Let me repeat again. Equal to, within brackets, sum of factor loadings into sum of factor loadings. This is the sum of factor loading square, divided by, now what we have to do is, again, sum of factor loadings into sum of factor loading, that is the factor loading square plus sum of measurement error. So this is now what we are going to calculate. If you click enter, the value will come automatically, right? So similarly, we can do the same construct reliability values for this. So for perceived ease of use, so let me see, equal to, bracket open, sum of factor loadings into sum of factor loadings, divided by, open the brackets, and again open the bracket because we are summing two variables, sum of factor loadings into sum of factor loadings plus sum of measurement error. Click enter. Right? So if you follow the same for attitude equal to factor loading value into sum of factor loading divided by within brackets sum of factor loadings into sum of factor loadings plus measurement sum of measurement error. Right? And for the last equal to sum of factor loadings into sum of factor loadings divided by sum of factor loadings into sum of factor loadings plus sum of measurement error. So these are the values, these are the construct reliability values we got, right? So these are the average variance extracted values we got, right? So this is the calculation of average variance extracted and convergent reliability. So please save this Excel file. Suppose in future, if you got any other variables, suppose you can change this part. Suppose in other research you have calculated the perceived behavior control. The variable name is perceived behavioral control 1 and the variable is PBC. Suppose just see here the factor loading you got is 0.768. So please see the yellow values how these are going to change if you paste. So I have entered 0.768. So see the change in the average variance value, average variance expected and construct reliability, right? So like that, if you change any item, it is 0.691. Suppose in another study you got 0.879. So see the change in attitude values, 0.59112 to 0.664. So this Excel sheet can be worked as a template for your future studies. So that's why I asked you to prepare this Excel, and this will become as the template for your future research. Maybe you have a doubt, sir. Suppose what happened if there is another item in my study. Suppose for PBC you have used 5 construct or 6 construct. Then how to calculate this? Even in that case also you can use the same template. You can simply insert another row, and you can simply click and drag these values. If you simply click and drag these values, and the formula will automatically apply. The value will change automatically. So this can be used as the template for your future studies. So please remember. And how we are going to report all these, right? So far we have calculated the AVE and CR, and this is the model we have developed, and these are the values we have to report, right? So see, we have reported factor loadings, right? Item, delta, and average variance expected, and all those, right? And then we have to calculate the discriminant validity table. So how we are going to report this discriminant validity? This is the last stage in confirmatory factor analysis, and in the next step we are going to calculate the hypothesis. So how we are going to get the discriminant validity table? So again go to the MOS output. So in the MOS output, we have copied the standardized regression weights from this table, and followed to that table, there is another table which represents the correlations, right? So copy that correlation table, right click, copy, and open the same Excel file. So you can paste that correlations in the bottom, right? And now what this discriminant validity explains is, let me show you the slide. So while we are calculating the discriminant validity, yes, this is the pattern we have to follow. So we have to report the discriminant validity in this file. So this is the reporting pattern of discriminant validity. What discriminant validity states is discriminant validity explains that all the research constructs we have used in the research are different from each other, because it will also says that the customers, those who are responding to our survey, they perceived each construct as different construct. They have not considered all construct as similar. So that indicates the discriminant validity. We followed the Farnell and Larker criteria 1981 for reporting the discriminant validity. We can also follow the HTMT correlation model also, heterotrait and monotrait correlation for reporting the discriminant validity. But in this FDP, I am going to explain how we are going to report the discriminant validity, right? So here all the diagonal values which are bolded in the diagonal are the square root of the average variance extracted value of the construct. So let me go to the Excel file again. So what are the research construct type? What are the research construct we have used? PU, PEU, and attitude, and BI. And again same in the vertical, PU, PEU, attitude, and BI. Now here in these diagonal values we have to calculate. So here if you see this cell, that is the impact of PEU on PU, PU on PU. So here we have to calculate the average variance extracted value of the perceived usefulness construct, right? So let me calculate. That is equal to square root of AVE value of PU, AVE value of PU. This is the AVE value. So if you click enter, by default it will automatically loads the value, that is 0.768. Next for PEU, equal to square root of AVE value of PEU. Enter. Next, that is the attitude and attitude, equal to square root of attitude AVE value. Just I am highlighting for your reference for the visibility, equal to square root of BI. So these are all the square root of AVE value, and followed by what we need to post. So we have copied the correlation table. So from this correlation table we can post. Suppose it is if you consider this cell, that is J26 in my Excel cell, it is the correlation between PU and PEU. So from this table PU and PEU, it is 0.729. So simply copy this 729 and paste here. And next, if you see, this is the correlation between PU and attitude, PU and attitude. So what is the value of PU and attitude? That is 0.418. So copy paste here. And next, PU to behavioral intention. So it is PU to behavioral intention 0.659. So simply copy and paste here. Right. Next, this is the cell which indicates the correlation between PEU to attitude. So PEU to attitude is 0.409, right? And it is PEU to BI, PEU to BI. This is the value. And attitude to behavioral intention, this is the value. So this is how we are going to prepare our discriminant validity table. Right? I think you are able to see. Now copy the same from Excel and you can paste wherever you want to report your data. So this is the discriminant validity, right? So what so far we have did, right? So we have did first the normality test, and then reliability test, and then we have calculated the average variance extracted, and now we have calculated the discriminant validity. So in the discriminant validity, what is the rule that has to fulfill is the remaining values which comes under the diagonal should be less than the square root of AVE. Suppose if you consider the first column 0.780 is the square root, that is the square root of AVE of PEU. The remaining values 0.729, 0.418, 0.659, all these should be less than 0.780. And if you see the second column 0.776, that is greater than 0.409, 0.632. And if you see the next one 0.769 is greater than 0.467. If our data shows this type of discriminant validity, our data is perfect for proceeding further, right? So after that, we are going to report the model. So now we are at the end. Now we are at the end of the analysis. So we have to report the model fit values. So what are the model fit values? So if you see the MOS output, so far we are in the estimates visibility, and now we have to click on the model fit. If you click on model fit, another separate table will appear. So from here, what we have to check is first we have to check the chi-square to degrees of freedom. From this table, simply we can simply we can copy this table and we can paste in Excel, or directly we can see the value and we can type, right? So what are the points we need to report, right? So what we need to report is we need to report the chi-square to degrees of freedom, that is 1.858. So this is the chi-square to degrees of freedom value 1.858. And after that, we have to report any goodness of fit values, right? So any goodness of fit index values, it is CFI, TLI, IFI, RFI, NFI, all these we have to report, right? Any one goodness of fit value, and wait, right. So these are all the values we can report in our report. So all these are not required. So chi-square to degrees of freedom and CFI, comparative fit index, or TLI, Tucker-Lewis index, and RMSA, root mean square error of approximation. So all these we will get from this research output, right? So if you see RMSA, this is the RMSA value, which is highlighting RMS, root mean square error of approximation, right? So I have given the threshold values for each variable. So what is the recommended value? Chi-square to degrees of freedom, it should be less than 3.0. Some cases we can also take this chi-square to degrees of freedom value should be less than 5.0. And other values, goodness of fit, adjusted goodness of fit, normed fit index, all these should be greater than 0.9. And RMSEA value, root mean square error of approximation value, should be less than 0.08. And I have reported another value, that is standardized root mean square error, root mean square residual SRMR value. We can calculate that SRMR value from our model. So I think you have drawn this model. So how to calculate the SRMR means we have to go to plugins, click plugins, and here at the end standardized RMR. So we have to click standardized RMR. So now we have to click on calculate. If you click on calculate, that will calculate and displays the SRMR value 0.0435, right? So the same 0.0435. This is what we have reported. So far what we have did, we have did all the analysis relating to the confirmatory factor analysis. And finally, we have to calculate the structural model to show what is our hypothesis, right? So how we are going to test the SEM. So from the same confirmatory factor analysis, we can draw this structural model. So let me have a quick look into it, because I think we are at the end of the time. So this is the confirmatory model. So I am selecting the erase objects icon. So please follow erase icons objective. I am deleting all these, right? And I am selecting this moving object. And also please see here preserve symmetries means that will move one complete variable. So perceived ease of use. So attitude is attitude and behavioral intention is an independent variables. So I am rearranging these two, right? I am rotating the attitude and I am rotating the behavioral intention, right? So what are our hypotheses? Now see here it is draw the paths. I am selecting this left side one directed arrow, right? So our hypotheses are perceived ease of use has impact on perceived usefulness. I am drawing one line, and perceived ease of use has impact on attitude, and perceived usefulness has impact on attitude, and perceived usefulness has an impact on behavioral intention. So behavioral intention is the last variable, right? And attitude towards using has impact on behavioral intention. This is how we are going to calculate the structural model. And remember, so here whatever the variables which does not representing by any directed arrow is an independent variable here. So here PUU is an independent variable, and PU is an dependent variable, and attitude is a dependent variable, and BI is a dependent variable. So all these dependent variables has to be marked with one error term. So here if you see the icon from the left side, add a unique variable to an existing variable, right? So add an existing variable. So please select this icon and move to that variable and click. And again for attitude, click one, and for BI, click. Right now label it with some error terms. Go to plugins and name unobserved variables. By default it will. Right. So now please save this file. Right. So now we have to calculate this, and simply analysis properties we have already given in CFA, and this will ask file save as. I am saving this file with FDP underscore tam, right? I am saving this and I am running the analysis. I have run the analysis, right? So the model, the analysis is completed. How we know? Because this is highlighted. So if we click on this, the values will load automatically, right? So again, so go to the view text icon. If you click the view text icon, this will shows what is our nodes for model, and go to estimates. So if you go to estimates, now the hypothesis testing result values will be shown in this output. So if you see the impact of perceived usefulness on perceived use is that is estimate is 0.834, where the P is 3 star, means P less than 0.001. Simply copy this table and open any Excel and paste this in the Excel, right? So remaining remove, delete all other variables except the hypothesis. I am selecting and deleting. Standard errors here. These two are also not required, but some researchers will report these also, but we need the estimate to know whether our hypothesis is significant or not, right? So this is H1. We propose this is H2, H3, right? H1, H2, H3, H4, and H5, or maybe order may be changed. First, whatever we have proposed. So this indicates PUU has significant impact on PU. These are the P values, right? So let me show that table also. So this is the structural model, and this is our overall results of the hypothesis, right? So this is how we are going to report. Triple star indicates that is P less than 0.001. Here if you see 0.029, right? How do we know p less than 0.05? What we have to do is if it is p less than p equal to 0.029 means multiply with 100, that will comes as 2.9. So 2.9 means less than 5, right? So that is how we can report this. So overall we have to report this hypothesis value, and we can also report the modification, the model fit values for this SEM also. But whether it is CFA or it is SEM, any one model fit values reporting is enough as per the literature. So this is how we are going to test the proposed hypothesis, right? So how we are going to report all these then? So let me have a very quick review, that is reporting. So in the report, what we are going to, so these are the proposed hypothesis and this is the proposed research model, and these are the questionnaire, and this is the measurement model, and these are the factor loading values. We have to report like this, right? So construct item mean standard deviation. So I have not shown these two, and I have shown factor loading, composite reliability, alpha. All these we can calculate. How we will get the mean and standard deviation? So let me have a quick view. So open the data file again. So go to analyze, descriptive statistics, frequencies. How we calculated the skewness and kurtosis like that. So actually if you open that, all these values will come this side, move to this side, and click on statistics. In the statistics, click on mean and standard deviation. These two are enough. Skewness and kurtosis already selected. Deselect those two and click continue and select OK. So if you click those, you will get the mean and standard deviation. So simply copy this table, click right click and select, and you can post those values here. So from here, you can calculate, you can copy paste these values in the report. So these are the values we have reported, mean and standard deviation, right? So this is what we are going to report, and after that, this is how we are going to report. Suppose for one variables, I am going to explain. For one variable, if you take an attitude towards use was assessed using 4 items, attitude 1 to attitude 4, with factor loadings between 0.691 to 859. So here we have highlighted about the factor loadings, which are ranging from 691 to 689, right? And the composite reliability was 0.801 and Cronbach alpha value is 0.847, both exceeding the recommended values 0.70 threshold. The average variance extracted was calculated to be 0.591, establishing convergent validity. These results confirm that the attitude construct exhibit good measurement properties. Like that, we have to write others also. For discriminant validity also, we have to post the table here, and we have to explain the discriminant validity. So here you can see, according to Fadler-Larker criterion, discriminant validity was established if the square root of AVE for a construct is greater than its correlation with the other construct. In this case, all constructs satisfied this condition. For example, you can write some examples, and this is the model fit reporting, and this is the structural model, and this is the explanation for the structural model. These are the results, and these are the explanation for the results, and this is the SEM model fit, right? So that is very quick and brief view of structural equation modeling. So now I am open for any questions from the participants.
Hello, sir. Thank you for the nice presentation, sir.
Yes, ma'am. Thank you.
Sir, I have one query.
Yes, ma'am.
Sir, in the final structural model,
Yes, ma'am.
in the final output, you have given different significance levels, no, sir? Like P is less than 0.01
Yes,
and
yes.
another one is P is less than 0.05, like that. Why different significance levels has come, sir? Usually we will be selecting any one, no, sir?
No, no, ma'am. I will give clarity.
Mm.
Let me open the file again.
Mm.
So let me share my screen, ma'am, so that
Yes.
ma'am, are you able to see the screen, ma'am?
Yes, sir. Yes, sir.
Yes, ma'am. So this is the SEM output we got it, ma'am, actually.
Hmm.
So in this report, so what is the value you are seeing from perceived ease of use to attitude? That is the second value. So what is the p value you are observing, ma'am?
0.029, sir.
0.029. Actually, we have to report this p values, ma'am. So 0.29 means what percentage, ma'am? Percentage means simply you can into 100, right? If you multiply with 100, that is 2.9.
2.9.
2.9 means less than 5.
Hmm.
Right? Actually, the probability level we will take is 5. The error term we will take is p value is always 5. 3 star means, ma'am, that is there is no error. But actually, we have to report that is as 0.001. That means 0.1%. If there is any value, suppose if this value is instead of 0.029, if it is 0.002, then what is the value you got? 0.2, right? 0.2 means multiply with if you multiply with 100, that is 0.2. That means we have to report that as p less than 0.1. So for reporting p values, we have to report in 3 ways: whether p is less than 0.001, p is less than 0.1, p is less than 0.5. So based on the p values which we get, based on our analysis, we have to report, ma'am. Is it clear?
When we are determining this P level, sir, significance level?
That is usually, if it is less than 5, we will accept the hypothesis, ma'am. That is the 95% confident interval, ma'am. P equal to 5 means that is 95% confident interval. 5% is the chance of error, ma'am. So you will accept the 5% chances of error in social science researches, ma'am.
Okay, sir. Sir, in SEM, where we are determining this confidence level or P level, sir?
In SEM, ma'am.
Hmm.
So in the output, we are calculating all these, ma'am, from the output, right? So from the bootstrapping, you can select all these, ma'am. Here it is 90% confidence level, percentile confidence intervals, right, ma'am, in the output. So here in SEM, it is the analysis properties icon, ma'am. Here we have to click this. By default, it will take automatically, ma'am. It will calculate up to 90%, ma'am, by default. If you select this, that will automatically highlight. So here, if you want to calculate with 95%, that will take 95%.
Okay, sir. So one more doubt.
Yes, ma'am.
In measurement model, for these independent variables, for at least one item, it is taking one number, no, sir?
Yes, that is the regression weight, ma'am.
Why that one regression weight is coming, sir?
By default, it will come as one regression weight, ma'am, because this PU1 is fixes as one item, and that will give freedom for other items to calculate internally, ma'am.
That means that PU1 has more regression weights, huh?
No, ma'am. We can use any item for regression weight as 1. Because how similar PU2 is PU1 or PU2 is PU3, how we can calculate? That's why we have to take one item as a base. By default, if we click the model, if you click from this first item, by default, it will add automatically the regression weight, ma'am. Suppose if we don't want the regression weight 1 for this PU, then we can go to the parameter and we can remove the regression weight here. And we can add the regression weight to PU3. This is the PU3. So now where you are able to see the 1, ma'am?
PU3, sir.
PU3. So because manually I have changed that.
Yes, sir. That means it has strong relationships, sir.
No, ma'am. That is the base for other items to calculate the correlation between others.
Okay, sir. Thank you, sir. Thank you so much, sir.
Yes, ma'am.
Dear participants, if you have any other doubts, you can ask. Shankar sir, please see chat box, sir. There is one question.
Chat box. How to write analysis for path diagram in MOS while computing construct reliability? YR entered double brackets on denomination. That is the calculation, I think SRKK. So that is the formula we have to use, sir. So let me share my screen again. Sir, are you able to see the formula for calculating composite reliability? You are asking about this, sir. So we have calculated the standardized loadings first. First we calculated the standardized loadings. So let me share that Excel also. Right, sir. So I think sir is asking about this, why we have used double brackets. This is, sir. Because that is the formula, sir. Here we have to calculate the sum of standardized loading square divided by sum of standardized loading square plus sum of measurement error. So that is why I have calculated. So if you see the first one, that is the sum of factor loadings into sum of factor loading. That is sum of factor loading squares divided by same value plus sum of measurement error values.
Okay, sir. Okay, sir, I understand.
Okay, sir. Thank you. Vijayasri ma'am, you raised your hand. Any doubts, please unmute your mic and ask me, ma'am. Vijayasri.
Just ma'am, please respond. Vijayasri ma'am.
I think madam has asked her doubts.
Okay, sir.
Maybe
Dear participants, if you have any other doubts, you can ask.
participants, do you have any doubts?
Dear participants, if you don't have any doubts, we can wind up the session for the day. Okay, sir. Thank you so much, sir. Shankar sir. Thank you
So
for your
if anybody has any doubts, you can mail us your queries. I'm sharing my first slide, so you can get my contact number and my email ID. So further, if you want to ask any doubts regarding this presentation or this topic, or maybe if anybody is willing to collaborate for future research works, so you can feel free to contact me through that email ID and through that mobile number. I think 4 chats. Thank you, sir. Okay, okay. Okay, sir. Yes, sir. So can we wind up the session, sir?
Yes, sir. We can wind up, sir. Thank you, sir. Thank you so much,
Yes.
sir.
So I thank very much for Acharya Institute for inviting me as a resource person for this program, and I especially convey my heartfelt thanks to Dr. Venkaya Babu Garu, who is the coordinator for this program. So thank you very much for giving this opportunity to deliver my session in this program, sir. And I hope great success for your FDP. Thank you very much, sir.
Thank you, sir.
I will
Thank you
look
so much.
forward for your future associations also. Thank
Sure,
you
sir.
very much, sir.
Sure,
Thank
sir.
you.
Thank you, sir.
Can we leave, sir?
Yes, sir. Yes, sir. Yes, sir. Thank you.
Thank you, sir. Thank you.